Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today we shall be discussing the very last example of a sequence IGCSE 9 to 1. And we shall be talking of, or rather applying the formula, and later in this video I shall be able to explain how to derive the formula itself. And you're told that the first term, and you're looking at example 14. Example 14 talks of the first term of an arithmetic series. Anytime you hear arithmetic series, of course, there is a common difference. The first term of arithmetic series is 5, and the 20th term, A, is 5, and term 20 is 81. Find the sum of the first 30 terms. So the question is, find the sum of the first 30 terms. It goes without saying that if term 20 is equals to 81, yet we know how to write term n. If we talk about term 20, generally like term n, we're going to talk about term 20 to be equals to a plus n minus 1d, n minus 1d. Because you remember we said that term 1, term 2, we're going to talk about plus, term 3 plus, all the way, this is a plus d plus a plus 2d. And we said the number of these are 1 less than the possession of that particular term. So the number of these, in this case, instead of writing n, we talked about 20 minus 1, which is basically 1 plus a plus 19d. That is it. Because you realize that for each and every term, the number of these in an arithmetic series is 1 less than the position of the term. So the number of d in the 20th term should be 19d, and that is just like it. So incidentally, we know the value of the 20th term. And we have seen a plus 19d is equals to 81, and a is equals to 5. So let us substitute 5 plus 19d is equals to 81. It goes without saying that 19d is equals to 81 minus 5, which is 76. And the common difference, if we divide both sides by 19, we're going to get our d to be equals to 4. Having done that, then we can talk about the sum of the first 30 terms. We have a, we have d, and we have n. So the sum of the first 30 terms is 30 over 2. We are now quoting this formula. 2a, which is 5, a is 5 times 2, 10, plus 30 minus 1, which means 29, times d, which is 4. Of course, this one must take us there. What are we saying? We're talking about 29 times 4 equals that, plus 10 equals that, times 30 divided by 2 is 15, so times 15, and that is 1890. And that is just like it. Having said that, I think it will be very easy now to prove the formula. Let's now go to proof. Proof of Sn is equals to n over 2, 2a plus n minus 1, d. Proof of that. How do we prove that? We said somewhere in the beginning in one of my videos in this topic that if you want to talk about the sum of the first n terms, the sum of the first 5 natural numbers will be S5 will be 1 plus 2 plus 3 plus 4 plus 5. And we can also start from the last one. The sum of the first natural numbers again will be 5 plus 4 plus 3 plus 2 plus 1. And you can see we have double sum of the first 5 terms, which is 6 plus 6 plus 6 plus 6 plus 6. In other words, we get a common sum how many times? N times. In this case, our n is 5. So we get 6 terms. We get a common sum 6, 6, 6, 6, 6. How many times? 1, 2, 3, 4, 5. So if we just want to get the sum of the first 5 terms is 6 times 5 over 2, which is simply we divide by 2. This is 6 times 1, 2, 3, 4, 5. Because we need the number of the first 6 terms, we simply divide by 2, which is 15. In the same way, we get the approach of this. The sum of the first general terms of an arithmetic sequence or series is a plus d all the way plus a plus the very last one, assuming we have n terms. Again, we can start with the last one, a plus n minus 1d, plus the second last, plus a plus n minus 2d. That's the second last term, all the way until the first term. If you add the two, you're getting 2 sum of the first n terms. And I want us to concentrate on a plus a plus a plus n minus 1d. You simply get 2a plus n minus 1d. Again, you get the same sum here, and you get the same sum here. All the way 2a plus n minus 1d. Incidentally, we realized that we did not require double the sum. But wait a bit. Here we got 6, a sum of a common sum. How many times? 5 times, because we are dealing with the first 5 terms. Here we should get the same sum, a common sum. How many times? N times, because we are dealing with the first n terms. So we are going to talk about the double the sum of the first n terms is n minus, or rather multiplied by 2a plus n minus 1 d. We got this term, we got this sum n times, and because we want just the first the sum of the first n terms, again we divide by 2, to get our famous formula. The sum of the first n term is n over 2, open brackets, 2a plus n minus 1 d. And this is how we derive that formula. It's not so much important to know how to derive the formula as far as now is concerned, but it is very important to know how to use the formula. Deriving, yes, you should, because of your proof and everything else, but it's not so much important. I will not require you at this level to master how to derive the formula. But of course, as a mathematician, you should be keen. Just learn how to derive it, but of most importance, learn how to use it. All right.